Dear participants, once again, welcome to our session is now AI-enabled block smart contracts, and the resource person is Dr. Santosh Kumar, head global technology team at AICTE Bangalore. Okay, hope I am audible, right? Uh, Let me introduce the speaker, Dr. Santosh Kumar. He has over 20 years as a technologist and solution leader in digital transformation, industrial automation, consumer electronics, and embedded systems, specialized in enabling adoption of new technologies and solutions by building business case, technology strategy, and skill competency development. And he is having experience over 20 years, and he has worked as WS Atkins, which is already mentioned, and previously he has worked on Pro Digital as practice head, and uh, he holds a PhD in Alliance School of Business and PhD in Organizational Innovation. And he holds a PGPM in Software Engineering at Indian Institute of Management, Bangalore. And he holds a Bachelor's in Computer Science Engineering in UVC, Bangalore. And he has patents like dynamic advertisement, queue management system, and federated network connectivity manager. Yeah. On behalf of the management, I welcome you, Dr. Santosh Kumar, sir, for the session. Over to you, sir. Thank you.
Thank you. Can you just enable me as a presenter?
Sir, you can share your screen, sir.
I'm not able to share my screen. It is not giving me the option.
1 second, sir. 1 second, sir.
Yeah. Okay, let me know if you can see my screen. Can you see my screen?
Sir, it is showing us started screen sharing.
Okay, I think I need to restart. I don't know why.
Now your screen is visible, sir. Now visible.
Okay, so you're seeing my this one, right?
Yes, sir. AI enabled smart contract.
Okay.
First slide.
Okay, sure. Thank you. Good afternoon, everyone. So in the next hour and a half, what I will do is I'll just briefly touch upon how AI and blockchains are evolving together and how they're solving the problems with each other. Right. So what I will do is in the next 1.5 hours, 90 minutes, I will just give a brief introduction about smart contracts, some of the challenges associated with these smart contracts. I'll then give a brief recap and introduction about AI or artificial intelligence. And again, just briefly touch upon the challenges associated with the AI. And then I will then look at how AI is enabling smart contract and how smart contract is enabling AI. If there are any questions, you can interrupt me and ask the questions, or you can put it in chat. Yeah, let's keep this session interactive, right? So let's recap on what a blockchain is. Right, like most of you know, what it does is it gives me a decentralized mechanism or a decentralized network for any particular operations in a trusted environment, which is immutable, right? So basically an immutable transactions between decentralized entities in a safe and trustworthy environment. Right, so that's what these are the three things which I would want you to keep in mind throughout these sessions, because that will be the key pillar of how smart chain is interacting with AI and how AI is leveraging smart chains. Right. So now let's look at the typical workflow of a blockchain, right? I think most of you are familiar with blockchain. So basically the end user initiates a transactions. Transactions could be finance, transactions could be non-finance, right? So basically a blockchain supports both cash flow. Means basically you can have a Bitcoin where you can then trade or exchange the Bitcoins, or you can have basically a smart contract where you can basically define the terms of engagements between the parties and then take actions or initiate actions around that parties, right? So basically, if you look at it, once the entire concept of blockchain is event-driven approach. So basically, someone needs to trigger some actions for the entire blockchain network to start functioning. Otherwise, it is predominantly passive, right? Now, let's say the user triggers. Let's talk about, keep it very simple and just focus on the Bitcoin for a minute. Right? Let's say you have 100 Bitcoins. You want to send 50 Bitcoins to your neighbor, right? So in that case, what happens is you initiate a transaction through a client. It could be a website, it could be a mobile phone or any of the devices. Once the transaction is initiated, the transaction is sent to the blockchain network or nodes, right? So it is there as a pool. So it is added to the transaction pool. And then once the network in the nodes verify it based on the consensus algorithms, this transaction pool is entered into a block called as package, right? And this block is then broadcasted to the entire network to establish or to ensure that this transactions is approved and validated and acknowledged in that network, right? Once the consensus algorithm or the majority of them approves this transactions or set of transactions, then that block is added to the block to the chain, and then the transaction is committed or completed, right? And now your neighbor B would have received the 50 blocks which you have transferred, right? So again, just understand the mechanisms through which this entire transaction happens, right? So basically, if you look at it, whether it is the smart contract or whether it is the Bitcoin, right? The transaction is initiated, the transactions are validated, the transactions are acknowledged and committed, right? So that's the entire flow of blockchain. So now let's look at what is smart contract. Any questions?
Sorry to interrupt, sir. Participants, kindly mute yourself. If you have any queries, you can unmute yourself and ask.
Yeah, thanks. So basically, if you look now, let's take a look at what smart contract is all about, right? So smart contract is an agreement between two participating entities, right? So it could be any type of agreements, right? The terms and conditions could be different for different people, right? So which would be defined as a program or an executable code. This code or this contract would be applied or it will be made available on a particular environment. In this case, basically, it will be the blockchain environment. It could be your Hyperledger, it could be your Ethereums, etc. And basically, once the smart contract is created, then any of the parties, associated parties, can then initiate transactions. The transactions are nothing but the operations supported by the smart contract, right? So it is very similar to your Bitcoin, right? In Bitcoins, the Bitcoin is the asset, or the transactions are defined by Bitcoins. Basically, you can add, you can subtract, the Bitcoins, right? So basically you can just split the Bitcoins and then transfer the Bitcoins from to different parties, right? So similarly, a contract, it is not a finance element, but a contract is a piece of code, right? Again, this piece of code, when it is created, needs to be validated, verified by the participating parties, or what we call as signatories, right? And then it needs to be accepted, it's validated and accepted in the blockchain. So basically, our entire smart contract is now available in all the network nodes. So any parties, the relevant parties or associated parties, when they initiate the transactions, it will basically any of the nodes in the network can validate that this is a valid transactions associated with that contract. Right now, unlike Bitcoin, where the operations, right, whether the additions or the financial operations, the additions, the credit or debit operations are agreed, and there is only one what you call a contract, which is in this case debit and credit contracts between the participating entities in case of Bitcoins. Whereas in case of smart contracts, you can have n number of smart contracts, like, and that is what people refer it as DAO. Basically, the organizations or parties which are bound by the contracts which they define among themselves, right? So basically, I can have 1 million sets of contracts. So that means I'll have 1 million pieces of code which are validated and are resident across all the nodes in the contract, right? For example. So that's the key aspects of contract. So now let's look at an example of contract, right? So I know you all are familiar with the crowd sourcing or crowdfunding concept. So let's look at how the crowdfunding algorithms or the smart contracts can be implemented, right? So it typically in a crowdfunding scenario, what happens is you have an idea, you know that to implement that idea, let's say you have a project where you're saying that you can build a rocket which will go to the moon, right? And let's say it costs you 1 crore to create, to buy the materials, to assemble the rockets, and then to launch the rocket, right? So now what you will do is you will ask the participating parties, right? In this case, the entire public associated with that particular blockchain, to share, to give some amount of money to you, basically, so that you pool together the 1 crore required to launch your satellite, right? Let's say that your satellite launch is successful and you're able to sell and you're able to make double the revenue. So let's say you get the revenue of 2 crores. So in that case, the people who who funded you initially would get a percentage of the profits back to them, right? So that is, there is an incentive for the people investing in your idea, because there should be some incentive for the participating entities to invest in your idea. So typically, what in the blockchain terms, what you do is when someone is investing in your idea, you give them a token. Token is nothing but a percentage of shares. You can just assume that it's just a percentage of shares. In this case, it could be 0.1%, or it could be 100 times the money which they're investing, right? So you have entered into a contract saying that these are the people, right? So you said that since you are asking for 1 crore rupees, you will have the equivalent tokens, or whatever the multiplier, whether it's 0.1 or 10 or 100, the equivalent tokens. And when anyone contributes that amount to you, you share back that token, right? So now this is a contract where you have, when you start, you saying that you need in this case 1 crore rupees, and then let's say your these 1 crore rupees you want to get from 10,000 users. So that means you will create 10,000 tokens, which then you can give it to the people who are funding you. So that is a simple example of a contract which where it's also called as initial coin offer. So most of the blockchain applications have raised money through the initial coin offers, and today you can see the price of Ripple or price of Bitcoins, etc. Right? So that's an example. Now, if you look at the blockchain, there are different blockchains. Ethereum, Hyperledger is the key ones. NEM is basically the Chinese blockchain, right? So the code which is written, or the smart contract, the language in which the smart contracts are written are basically varies depending on the type. There is Solidity, which is basically the Ethereum. It's more popular, but of late with Hyperledger, I think Java is becoming more and more popular because the developer ecosystem is very large in terms of Java, right? And the other thing which I want to highlight is the contract needs to be executed in an environment. I said the blockchain is the entire blockchain is an environment, right? So basically each of the blockchain node would provide a safe executable environment, very similar to your Android application. So you have your Android runtime, you have your Java runtimes, etc. So similarly, the blockchain, they will have a virtual machine, what they call as, in case of Ethereum, it is called EVM. In case of Ion, it is called AVM. In case of Hyperledger, it is prominently the Dockers, etc. So each of these environment would be provided where your smart card contracts would be executed or will be running when any events or transactions triggers that smart contracts, right? Now, there's a big challenge in research going around the turning completeness of that particular smart contract environment, right? Because there is a huge amount of effort required to code your contract. Once you have coded it, you need to ensure that the denial of service attack doesn't happen through smart contract. So when you say denial of service, basically, let's say you accidentally write a infinite loop, right? And then when you trigger the transactions, your blockchain node will continuously go on computing, and it will never come out of that contract transaction executions. So there are various restrictions and challenges which we need to look at. So there is a huge effort and a large amount of timeline. I'll talk about that when we talk about the challenges. So there is a huge challenges in codifying the contract and ensuring that the contract is execution for any transactions is deterministic and completes within the resources required, right? So far, any questions on contract, smart contracts? If please, as I said, you can just keep posting your questions on the chat window. The key advantage of smart contract is, again, the basic premise of blockchain to eliminate the middleman, or to eliminate the centralized entity and basically make a decentralized way to mechanisms to execute a contract. So basically what smart contracts does is it gives you the autonomy, right? So it eliminates the intermediary in terms of lawyers, right? It establishes trusts between the parties, right? So though you have entered into a contract, you can trust that when you're giving a money or making a transactions or triggering a transactions associated with that contract, the actual delivery happens, right? As I said, though we are avoiding the legal back and forth exchanges between the legal, the central banks, etc., we are still introducing the development of the software, the contract creation entity, but the time lag savings compared to the traditional contract to smart contract is still very high. right? And since it's done in the virtual mode, it is safe, and since the smart contract execution happens in a distributed manner, the resources and the infrastructure required are quite efficient, because it will be shared across multiple participants and multiple contracting entities, contracting objects. Yeah. Did someone have any questions? Okay. Let me just look at what are the costs associated with smart contracts. Like, so I think blockchain, we all know it is free. You can enter you can basically just enter into the Ethereum network, or you can enter into the Hyperledger network, and you can still entertain. Basically, you can start your smart contract, create a smart contract and initiate the transactions. But there is a cost associated, because there are costs associated with the participating entities and the resources which are used to basically honor and basically complete your smart contract transactions, right? And that is what is called as gas limit or gas fee. Basically, it is the smallest. So basically, the gas fee is based on the amount of gas consumed for the entire smart contract transaction execution or processing, right? So gas unit is the smallest operation, right, which is possible within the virtual machines for a particular the type of operations, right? Because again, the virtual machine will say that these are the predefined costs associated for whether it is the validations, the verifications, the broadcastings of the transactions, etc. Right? So all of that will add up, right? So every time you make a transaction, there is a hidden fee, or now what do you call the amount of gas which you consume for your transaction. Basically, that is what we call it as the gas limit or the gas fee, which is the charge which you'll incur when you're executing any transactions. The advantage of the gas fee compared to the traditional fee is that only when you initiate the transactions, only to the extent of the operations which is associated for that particular smart contract transactions, that is the fee you will incur. Unlike in a traditional smart contract fee, where you upfront define whether you incur, let's say, your whether you default or you don't default, whether that service is triggered or not triggered, you still have to pay that fee. So that is another advantage of smart contracts. Okay. Any questions? Okay. So that's on these smart contracts. So let's now jump into artificial intelligence, right? Again, I'm not getting into the technicalities of the artificial intelligence. I will just focus on the problem statements and just give the high level view of artificial intelligence, right? So now let's look at what is artificial intelligence, right? There is no one single definition of artificial intelligence, but if you look at broadly, they will artificial intelligence means using machines to solve a particular problem or automate the decision making aspects of humans, right? So if you look at the artificial intelligence, there are two major techniques or methods of artificial intelligence. The first one, which is the logic and rule-based approach, it has been there in the earlier days. It is prominently associated with your decision-making systems. Basically, the user or some predefined rules are there. And then basically the machines automatically execute those rules based on certain conditions, based on certain equations, based on some mathematics, algorithms, your regression classifications algorithms. I think most of us today use this. For example, if you're watching Netflix or YouTube, you'll always have the recommendations, right? You might like this, or if you're buying in Amazon, it will tell you that based on your search, people have bought these, right? So there is an algorithm, rule-based algorithms, which has a predefined set of parameters. Based on that, it will suggest what actions or what actions needs to be done, right? Uh, Here in this logic based, as I said, the features and the parameters are predefined either by the data scientist or by the domain specialist or the subject matter experts, right? In machine learning, which is basically also called as pattern-based approach, right? You're feeding huge amount of data sets, right? So basically, based on the historical data, it identifies the pattern, right? And then based on that pattern, it creates the inference rules, and then it applies that inference rules, right? So for example, the autonomous vehicle, right? So basically the driverless cars, etc., where uh, based on the traffic data, based on our driving behaviors, there has been tons and tons of data which has been collected. Based on that data, now the different sensors, the different elements, mechanical elements interacts with the environment, and then the computer or the algorithm makes decisions and basically triggers the actions associated. Right. Of course, now the machine learning has gone into something called as deep learning, where you have minimized the your operation set, right? So basically, rather than abstracting out, you are going to the nth level of details. You are also doing the reinforcement learning. So based on the decisions and the reactions, you infer and you continuously learn in a loop, right? So some of the examples of this is basically these days there are, I think, most prominently in the defense or in the interspatial orbit, like your ISRO, the Mars rovers, etc. I think you have these autonomous defense vehicles where they are equipped to take actions very similar to your to human beings. Again, your Cortana, your Cities, Sophias of the world, etc., fall into that category. Right? So let's look at the rule-based logic, right? So if you look at the automation, the artificial intelligence piece of it, the rule-based logics tend from basically mimicking the human behavior, where you have a predefined rule set, to basically making intelligent decisions, right, based on the rules. So I think that's where you see that the lowest denominator is the robotic process automation, where you define the rules saying that this is what a human being does, so the computer needs to repeat whatever the human being does, right? So if there is any deviations from the input given, then it will not execute that particular, it will not perform that particular actions. The next one is uh, the intelligent automation, where basically it says that, okay, there is a deviation here, but I think that you need to perform this action because of these conditions, right? So it is giving you a recommendations, like your Netflix recommendations. Either you want to watch, the humans take the actions on behalf of you, right? In the cognitive automations, what we do is basically it goes to the next level, where let's say you have in Google, in YouTube, you have this watch later, right? So let's say that based on your patterns, behaviors, etc., YouTube automatically detects that you will be most likely watch these movies. So it might download these movies onto your laptop or onto your home devices, and it'll keep it ready for your consumption. So basically here, 80% of the decisions are already taken by the machines, and only some let's say there is a new movie and it doesn't fit into your recommendation list, then in that case it will prompt you saying that do you want to save it, because it's a new movie and these are the genres, etc. So basically here it is not the fullest automation, but I think if the probability of the match is 80%, it will make the decisions, the machines will make the decisions on behalf of you. Otherwise it will prompt the humans to make the decisions. The artificial intelligence is like your Watson. Basically it will guess and it will behave, mimic the human beings, where The human beings will only review the decisions which have been made and will correct the feedback algorithms if the machine makes any mistakes, right? So that's the extent of categories of AI, right? We'll talk about what are the nuggets required to reach that level of intelligence, right? Now, if you look at machine, any question? Okay, so if you look at the different types of machine learning, I think we all would be familiar with supervised learning. When I say supervised learning, it is the humans feed the data, feed the inputs, give a basic point of origin, and the algorithm evolves from that particular point, right? In unsupervised learning, right, the humans are not aware of it. The machines automatically detects, identifies the dimensions, and then it will basically give us the rules or identify the rules for predictions, right? In reinforcement learning, which could be either a supervised or unsupervised, where basically based on the feedback, based on the past actions, it will correct and it will reinforce the learning, either reinforce or basically modify the inferences so that the next predictions would be much more accurate. Right. So now let's look at what are the nuggets or elements required and how do I uh, build these AI algorithms or logics, right? So the typical elements is data, right? So uh, uh, especially the machine learning track or the pattern-based predictions require huge amount of data set, right? So the larger the data, the better it is. That's where today Google is able to, since Google, most of our search engines use Google. So that's where Google is able to do a better predictions. And similarly, Watson spent almost 15-20 years collecting the data to train and evolve the logic. So basically the data set needs to be very, very good, right? And we have seen what happened for the Cortana by Microsoft, right? Where it learned the curse words and started behaving erratically, right? So they had to redo the learning training algorithm. So it's basically what we call as garbage in, garbage out. So data quality is very, very key, right? And in today's world, I think whether it is Facebook, whether it is Netflix, whether it is Google, whether it's WhatsApp, the reason they provide the services free are basically to get our data, right? Once the data is there, then we need the data scientists to basically uh, create the training framework, right? So what are the algorithms, different mechanisms you will use, whether it's regressions equations, whether it is classifications, what is the probabilistic thresholds, etc., right? So there are different, and what is the uh, uh, sets which you will look at. So basically there are different parameters which the data science will play around to see and understand, which will minimize the errors and which will improve the maximize the training or the incremental jump in the inference or the prediction accuracy, right? So once the training is done, then you might have more than one model, right, for a particular problem. And then based on that, again, the data scientist would come in and they will learn, they will figure out, do the validations, and they will, based on certain statistical parameters, they will say that this is the best model for use or for deployment, right? So once that model is selected, then you deploy the model where based on real-time data or based on the data inputs, it will make the predictions or inference on your behalf and then generate the results. Right? And of course, once the results is there, whatever the logs which the prediction models, the execution model generates, that needs to be refed as a data for the training to upgrade or do the incremental learning algorithms, right? So that is the key. These are the three key elements, where one is the data, second one is the training model, models, algorithms, and the third one is the generated algorithms or the model itself, right? So I just want to ensure that you understand these three key aspects, because this will be the key elements which we will try and see how smart contracts can enable. Okay. As I mentioned, if you have any questions, please feel free to interrupt at any time. Right. Now let's look at, we just saw we did a quick introduction of blockchain and we did a quick introduction of AI. So let's combine both of them, right, and take a high level view. As I said, if you look at the AI, which is on the left hand side, you have natural language processing, automated learning, you have robotics, you have image based computer visions, you have regressions, reasonings, etc. You have different algorithms and capabilities which AI brings in, right? But the biggest challenge here is that AI is very data intense. So because it requires huge amount of data, that means most of the time today, if you look at it, whether it is Facebook or whether it is Google, they own your data and they have that centralized data, right? So there is a centralized entity. The second aspect of AI is basically the resources required, whether it is a data science skill set or any questions. Okay, so basically it could be whether there is resources in terms of your data science scientists, human capabilities, or it could also be the compute infrastructure, the GPUs, the FPUs required for undertaking the training and the prediction algorithms, right? So that's on the AI side of it. So if you look at blockchain, right, as I said, prominently, if I focus around the smart contracts, again, you have a decentralized mechanisms. You still need to have your network of blockchains. You still need to have basically a consensus and mechanisms to validate and a mechanism to secure your transactions, secure your uh, basically your blocks, which is there, validate and secure your blocks so that like for example, the double spends, you honor, basically you honor the contract, the terms and conditions given in the contracts, right? So that's the what the blockchain platform gives you. Basically, it's a decentralized entity, and AI is basically bringing in the intelligence and providing you the inference mechanism, right? So now let's look at how both of them can help or influence each other, right? So the way I have looked at it is I've just split that into two categories, right? One is how can I use AI to make smart contracts more intelligent or more sophisticated? That's the first set of category. Basically using AI for smart contracts, right? The second piece is basically smart contracts for AI, basically trying to decentralize the AI through in the form of smart contracts, right? So basically bringing AI in your hands of your mobile phone, either through blockchain or through smart contract technology, right? So I will start with the I'll just briefly give an introductions to each of this, because this is both these fields are evolving and they are still in their nascent stage. There are technologies and tools for each of them, but it is still not mature. It's an emerging area of focus. So anyone who's interested in pursuing their higher studies in these areas, you can get some of, you can identify topics in these areas for the research. So as I said, let's look at smart contracts, right? So in a typical traditional smart contracting way, what you do is the two parties who want to engage into a smart contract will go to a lawyer. The lawyer will draft the terms and conditions of the contract, right? and then he will go to the bank or the government entity to notarize it, bank to ensure that there is a escrow mechanisms in case of failure or providing the safety environment, and then there is a continuous monitoring of this contract, right? Most of the time, the failure happens in the execution of the contract because the terms and conditions would be so huge that it typically there will be an arbitration involved, right? If let's say you want to trigger any particular clause in that contract, then if one of the party refuses, then you will get into the legal arbitration process. There is a huge cost involved and time involved, effort involved, right? So that is your traditional contracting process. In smart contract, what your blockchain does is basically minimizes the operations and governance of the contract execution, right? So because you have codified, so basically again, let's say in the smart contract world, what happens is the two parties agree on the terms and conditions. They will go to a blockchain developer or a smart contract developer. The smart contract developer would codify these contract terms and conditions. And then both of these parties would approve or agree and approve on these smart contract, which is nothing but the piece of code. They'll ensure that, okay, it's functioning perfectly fine for all the clauses. And then they commit this smart contract into the blockchain environment. So the blockchain, the consensus algorithm, the validations, the verifications mechanisms, security mechanisms of blockchain technology handles the governance and operation. So it will prevent the arbitrations, or you will not get into the arbitrations clauses, etc. Right? But here again, the thing is you are dependent. Instead of lawyer, now you are going to a software development or the smart contract developer. So there is always a possibility of error in the software you develop, right? So how do you manage the errors, right? How do you ensure that the denial of smart contract services? How do you ensure that there are no loopholes, there are no hackers who can enter in and steal away your money or assets or tokens which is out there, right? And the other part of the challenge is, have you ensured that the developer validates the data? As I said, data garbage in, garbage out. And the challenge with the blockchain is once you enter or initiate a transactions, because it is immutable uh, smart contracts, you can't change. The change in the smart contract terms and condition is a very costly process and usually not allowed. They'll ask you to recreate a new contract, or basically you might have to undo the contract. So basically your cost of undoing the transactions because of wrong input parameters or wrong parameters is again very high, right? So basically these are the typical challenges which you see in your contract, right? So now let's look at how AI can help us solve these problems, right? So as I said, contract authoring is one of the big challenge because it requires development software developers to be associated with the contract creations. It also means that there is a huge uh, uh, lead time because there is a huge effort spent on validating the smart contracts by the parties associated, ensure that it is basically all the code coverage of the smart contract, the input validations, the parameter validations, the different parameter validations are handled, are valid, tested, etc. So there's a huge amount of effort, there's huge amount of activity even before smart contracts gets uploaded or deployed into the blockchain network, right? So with AI, basically the natural language processing, we could look at automating the entire transaction, creations of the entire transactions, right? Um, Again, we all know that there are Watsons, there are Google APIs, which will give us the English dictionaries for reading the legal contracts, and then there are tools which can automate the generation of the code. But then when you look at the legal laws, the English are very different from your day-to-day English, or the general English which is used. There are different terms which has different meanings in legal domain compared to the normal domain. So basically, this is where AI would need to build its own dictionaries for smart contracts to enable and ensure that basically you can automate the contract. So basically, Richard, one of the PhD student, had coined this term called contract tuple, which is basically the pose is nothing but the legal text which is fed into the NLP algorithms, the parameters basically, what are the variables which you will allow to change dynamically in the runtime, and which are the variables which will make it static during, and which will fix during the initialization times, etc. And the type of operations within the virtual machines of blockchain which is allowed, how you will undertake those, right? So there are a lot of challenges, but today there are tools. The Hyperledger is popular because it does provide some tools to which will simplify my smart contract creation times. Ethereum has enhanced the solidity to simplify the smart contract creations. But I think we still have a long way to go before just the parties involved in the smart contracts are able to create a smart contract code and deploy it confidently in the blockchain environment, right? I think, as I mentioned today, one of the other challenge with respect to the current smart contracting mechanisms is the quality of the smart contract. As I said, there are a lot of errors, there are a lot of issues which people may not always are able to identify. So basically, people have developed few AI tools, whether to increase the code coverage, whether to validate the parameters, whether to check at the different permutations and combination scenarios, etc. Right. So that is another. I think that this is predominantly, again, as I said, the Hyperledger has deployed a lot of tools around smart contract validations, etc. The other aspect of smart contract is, as I said, when each parties enter into a contract, each contract gets deployed into the blockchain. So basically, at any given point of time, the blockchain nodes would have n number of the smart contract codes associated with that particular with the different participating parties here. So basically, managing that entire resource is a big challenge, right? And again, if you look at the practical world or real life world, right, one contract may be linked to multiple other contracts. There might be a tri-party agreement, there might be a change request, there might be a different terms and conditions, there might be an MOU associated with the statement of work, etc. So there are multiple linkages, right? The moment I increase the complexity of my smart contracts, the time required to deploy my smart contracts will increase and basically will delay the entire smart contracting mechanisms. So again, what we are and because of that, what most of the blockchain technologies today do is basically they minimize the functionalities which can be the operations which can be performed within the smart contract. One, basically to ensure that it brings in the deterministicness into the entire smart contract operations. So what we are saying here is that we can use AI I think basically the ocean technology right now, which is evolving and which is becoming popular, they provide interfaces to the AI APIs where you can extend the functionalities beyond what is currently supported by the VMs, right? The virtual machines in the contract. So right now, if you look at what the contracts, smart contract transactions or operations you can do is limited, right? In case of Bitcoin, the global smart contract has about maximum of 5 returnable operations, and then I think another 5 non-returnable operations which it does. So I think, of course, the Ethereum provides a slightly more customizations. Hyperledger, Ethereum, etc., provides a slightly higher degree of operations, but then they also still basically restrict the overall operations that can be enabled or that can be used in the smart contracts. So that's another use where we could look at AI to predict, to enhance, to bring in the determinism in any type of operations that is required in the smart contracts, and basically enable the functionalities of smart contract. The other aspect, as I mentioned, is the interlinkages between smart contracts. Right. So today, if you look at most of the smart contracts, they are treated as the standalone entities, and there is almost zero relations established by blockchains between smart contracts. And that's where there are a lot of organizations which has come up with the a smart contract analytics tool using AI to basically predict the relationships, to basically leverage AI to understand predict the potential probabilistic transaction operations after a particular event has happened. So basically, the blockchain, which is an event-driven mechanism, suits very well to apply the AI-based analytics based on a trigger or based on an action which has been performed. Right. So these are areas which, again, as I said, in the last 2 years, 2018 onwards, it has been evolving, and people have looked at it. Again, there is a long way to basically go. So there is huge amount of opportunities here of applying AI technologies for basically increasing the functionalities of smart contracts and making smart contract more smarter. Right. So that is the first leg, which is basically using AI for making smart contracts smarter. Right. So now let's look at how we can make AI, how uh, uh, we can enable uh, AI for the masses, right? So we all know that data is the oil, right? So every data which as an individual we share, whenever we use Google's, whenever we use Android mobile phones, whenever we use Netflix, whenever we use Facebook or WhatsApp. So they're able to collect this data, they use this data, and they make intelligence, and they build these algorithms or the models for inferences. But these models are, though they are using your data, right, the inference models are not given back to you, right? So they don't give back the inference models, they don't give the data access, so you also don't have access to your own data, right? And recently, I think in the last couple of weeks, you must have seen that Google is basically is planning to charge for most of the services which it was offering as free, in spite of collecting your data, right? So earlier, Google was giving these services free, like your image, the Google Drives, etc., because it wants to understand and use the data which you upload, right? Now that it has enough data, now it is starting to charge us for our data, which it will use, and it will refine its algorithms, right? So I think there is a huge amount of economy and thought philosophy around basically you have to be paid for your data or for your preference which you share with these technology chains, right? And that's what we will look at, how smart contracts can enable us to monetize our data which we share. right? So let's again take a similar approach. Let's look at the current challenges of AI. So as I mentioned, one of the biggest challenge is the data, right? Garbage in, garbage out. So everyone wants quality data. As I mentioned, Google is in the past 15, 20 years, it has been operating, it has been providing free services so that it can use our data and it can train and it can make its algorithm much more efficient, right? The second aspect is basically the data science scientists who are able to basically come up with, identify the right algorithms to use to interpret the data, how to interpret the data, what to make sense, which data to use, how to cleanse the data, how to transform the data, etc. So I think there is a very limited skills right now. And again, uh, uh, few organizations have monopoly on these skills and you are not able to get the benefits, right? So they are charging a premium for that skill. They are not allowing us to basically bring the intelligence to the masses, right, if I might put it. Once that's done, again, if you look at it, the other big piece is the infrastructure required for your AI operations, right? When I say infrastructure, it could be your compute time, the compute power required, the storage powers required, right? So one entity, one single organizations, it is very difficult to store the entire worlds of data, and also to basically provide the infrastructures required to train and basically run the prediction models, right? So these are the at a very high level the challenges which which can be decentralized. So instead of giving the power in the hands of few tech giants, we can leverage smart contract and blockchain technology to decentralize. So here, when I'm talking about decentralization, I'm referring to decentralization of the data, which is used for training, decentralization of the actual training algorithms, right? So basically, if someone comes up with a new training algorithms or a different training algorithms, then it can be shared and it can be acquired for a fee, and it can be executed on your home laptops, on your home machines, or on your mobiles, etc. And the last one is the compute. Basically, when you're running the prediction algorithms, you don't have to buy a sophisticated machine. So for example, if you have to run a basic a Netflix type of recommendation algorithms, you need to buy a computer which costs you about 4 to 5 lakhs rupees. Basically, it requires the GPUs, it requires the RAMs, it requires the SSDs, the storage, hard disks, etc. Right? So the minimum for performing a simple weather prediction algorithms also requires close to about one server, which you need will cost you about five, and you might need a 3 or 4 cluster of these servers. So it'll cost us huge amount of money for us to do an upfront investment. Hence, since why not leverage, why not share the free CPU cycles available in all the infrastructures available in the world, right? So basically, a shared decentralized economy. Right. So, as I mentioned, what contracts enables to AI is basically it enables you to share your data, protect your data, ensure that the trained models which is built or generated out of data is used for you, or you are paid for that model which is built based on your data, right? So that is the ultimate nirvana of how smart contract can decentralize or put the power of data in the individual hands, right? So as I said, you have your data, right? Basically, is there a way in a secure and in an incentivized way for you to share your data to the data scientists around the world, right? So you know that how your data is being used, you know what the inference models you are your data is generating, so that you can monetize or you can use that inference models for all your decision making systems, right, or approaches. The second one, as I said, smart contracts will ensure that it is decentralized. So basically, in the first piece, it was all about data protections and data privacy part of it, right? Now, the second one is a decentralized execution, right? So here, different data scientists would have different algorithms. Is there a way in which smart contracts can ensure that it aggregates the model and basically generates a model which produces a larger results, like basically bringing 1 + 1 as 11, right, instead of 2. So basically here, again, through the power of decentralized executions, decentralized nodes, can I uh, can the smart contract enable execution parallelisms of multiple training algorithms so that you get a master powerful trained model at the end of the day, right? And the third area where smart contract can look at is, once the trained model is there, can I leverage that model? Can I use the infrastructure out on the blockchain to execute my predictions and generate the output based on some data which is out there, right? So basically, we are now talking about a AI model as a smart contract. Right. So that is what the in the recent, I think in 2019 onwards, people have been trying to see if we can create a AI model of smart contracts. Right. So I think I found this very interesting from 101blockchains.com, where it says that how I can decentralize and enable a collaborative, decentralized and a collaborative AI using blockchains, the smart contract construct, right? So as I said, let's look at each of these three elements. So for us, for any individuals to share the data, one, of course, I will have the privacy as a big concern. And I think we all know that the entire nuggets of blockchain is around revolving around privacy and security part of it. Uh, and the second aspect which blockchain brings in is the incentive mechanisms, right? So I think we spoke about the gas fee. So again, gas fee could be one of the mechanisms, or the tokens could be one of the mechanisms in which you could reward the person who's sharing quality data, right? Again, you can define what quality means, and based on that quality, you can define what type of premium you want to pay for that particular data. So basically, now you are incentivizing people to share quality data for the data scientist or for the AI ecosystem, right? Once the data is basically handled, right, the smart contract for AI can then not only define the incentive mechanism, but also can define the encryption, decryption, the content protection mechanisms, and the keep track of the usage of this data, the inference, whatever the inference model gets captured or built based on this data. The smart contract can track and can basically look at the type of let's say accumulations, basically, if I can say, accumulations of the incentives over a longer period of time. It is not a one-time, because the inference is not a one-time activity. It's a continuous ongoing process, and the logging and the tracing mechanisms which blockchain enables, the chain mechanism in blockchain technology, is very aptly suited for us to track the incentives for the entire life cycle of the AI inferences model, which is generated based on your data, right? As I mentioned, the incentive mechanisms for both for data, for training models, and for the prediction models are very, very key. And there are basically two main approaches. One is a gamified mechanism where uh, people incentivize you to collaborate for the betterment of the common good. Basically, they give you notional rewards. The second one is basically based on the predictions, the extent of savings which you have done. Basically, this is what we call as the result oriented rewards, right? So I think these are the two. I think the gamified rewards are inbuilt as part of your gas fee or gas limits, which we discussed earlier. I think the prediction based, the final outcome based rewards are evolving in the smart contract and in the AI world. Right. As I said, this is an emerging and evolving technology. We will touch on some of the tools and some of the players, which I just listed down in the diagram, on the different aspects where they are taking the AI and blockchain to the next level. Right. So basically, where AI is going from the decentralized and collaborative AI is basically the swarm intelligence. It's basically like every individual will have their own inference models, and basically we're talking about swarm of intelligence, where it aggregates all of these intelligence and it gives a meta intelligent model, right? Again, as I said, the key for this is the data set which goes, the trigger which goes in for that particular transactions and for that particular model. Right. So as I said, we will look at some of the evolutions which is happening in this space. So first, I think singularity is one of the popular uh, uh, smart contract mechanisms of AI. Basically, as I mentioned, it is a framework. It's providing a framework for us to extend the functionality of smart contracts through the smart contract wrapper APIs or the agents. So, if you have your own intelligent model, right? Singular net enables you to access that functionalities within your smart contract. So it provides the framework. It's one of the emerging framework for accessing or extending the smart contract functionalities by leveraging the AI framework, right? The open mind is basically, as I said, is a framework, again, emerging framework, which enables you to incentivize in a gamified way or in a gas limit, using the gas limit mechanisms, where it is enabling data science to use a decentralized data, right? Data across individuals or data across systems to generate a richer training algorithm. So again, it's one of the popular smart contracting way, which provides the data scientists to train the models using the data which is spread out across the world, right? The other tool which is again emerging in this area is Danku. It's basically a protocol uh, to for um, exchanging the intelligence or the minor training algorithms, right? The individual, the swarms of the intelligence to build a mastered intelligent algorithm. So again, it's evolving. It's one of the technologies which I would request you to keep track of and monitor in the coming years. Again, Ocean is, as I mentioned earlier, is again the framework for incentivizing the data exchange, the inference exchange mechanisms. So again, these frameworks will eventually get incorporated into the larger blockchain technologies like Ethereum, Hyperledger, etc. But these are right now working as an independent entities, and eventually in the next couple of years would get mainstreamed. Right. So that sort of, at a nutshell, I've tried to just give a gist of how AI and smart contracts and slash blockchains are converging or are interlinking to create a much powerful technology or platform for us in the coming years. So now I will open up the forum for any questions you might have. So any questions?
Participants, you can ask if any questions. You can unmute yourself and ask.
Okay, so if there are no questions, thank you all. Hope this was useful and insightful. I'm assuming that this would help you identify some of your research topics or research areas. So do feel free to reach out to me if you have any questions or if you need any support.
Yeah, thank you for your valuable session, sir. As sir has covered basic concepts of Bitcoin, crowdfunding, smart contract in detail, and pattern-based searching, and some of the important aspect in blockchain and smart contracts. Thank you, sir. Thank you for your valuable session, sir.
Thank you.
Thank you, sir. Participants, feedback link will be posted in the chat window. You can fill it. This is for taken for attendance. On behalf of the management and the Department of Information Technology, KCGF Technology, we thank you so much, sir, for your valuable session, sir. Thank you, sir.
Have a good day. Bye.
Thank you, sir.